This is Swathi, working as Assistant Professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal. This lecture will discuss about the transistor, its construction, and the principle of operation of transistor, and the various modes of, that is, various configuration of transistor, and the type of transistor we will be discussing, and how the transistor operates based on the applied potential. We'll see now. So first of all, what is a transistor and who invented this? That is, we'll have some brief introduction about transistor. So the transistor was invented in December 1947 by the team of John Bardeen, Walter Brattain, and William Shockley at Bell Labs, USA. So this is a team of 3 members who has invented transistor, and this transistor was mainly introduced for the amplification purpose. So what do you mean by amplification? Why the transistor is used? So it is also a semiconductor device. So here we have weak signals. In order to increase the strength of that weak signals, we need to have a device. So that device is nothing but transistor. Even we can also use this transistor as a switch also. So but the major purpose of transistor is for the amplification of weak signals. So the William Shockley was invented the junction version of transistor in the year of 1951, and they received a Nobel Prize in the year of 1956 for their invention. And he is the scientist who has invented this transistor. That is, who is one of the member of the team who has invented the transistor. He is Mr. John Bardeen, and this is Mr. Walter Brattain, and this is Mr. William Shockley. So these are the 3 members who worked for inventing and who worked very hard and invented a transistor, and they have received Nobel Prize for their work. And so before the transistor, we used to have a vacuum tube. So this is the basic vacuum tube which is used to perform the operation of amplification, and as it is very huge, so they have invented a device which can be very small, which can be smaller in size, and even which can perform the amplification of weak signals. So this is the first version of transistor, that is a vacuum tube. So here the invention of transistor is revolutionary, and the transistors are are invented to replace the vacuum tubes, which are very bulky in size. So as they are bulky in size, so this team has decided to invent another device which can replace the vacuum tube, which is very bulky in size. And here this is the image of basic vacuum tube. So here it was very bulk, that means the size of this vacuum tube was very huge, and due to that drawback, we have the team has invented a modern transistor, which is this one. This is the modern transistor, so which is a 3-terminal device here. So if you can compare the size of this vacuum tube with the transistor is very smaller in size. So now, coming to the introduction of transistor. So what is a transistor first of all? Transistor is also called as BJT, where BJT stands for bipolar junction transistor. So you have to remember that transistor is a 3-terminal device, that is 3-terminal semiconductor device, which is formed by connecting 2 diodes back to back. So as we all know, the PN junction diode, so in which P and N type materials are placed together so that a junction is formed. So here this BJT is a 3-terminal semiconductor device which is formed by connecting two PN junction diodes back to back. So what is this back to back connection? We'll see now. So and hence it has got two PN junction because we are connecting two PN junction diodes back to back. So in a transistor we'll be having two junctions. So that we have to remember. And the main purpose of transistor is it is used to amplify the weak signals, and it is also used for switching operations. That means we can also use this transistor as a switch which can operate as which can be either on or off based on the region of operation. And the three terminals which are drawn out from the semiconducting materials, and those three terminals we will be discussing. What are the three terminals? Before discussing about the three terminals of a transistor, we have basically two types of transistor. Depending on the type of construction, the transistors are classified into two types, that is NPN transistor and Pnp transistor. So what is NPN transistor and Pnp transistor? So an NPN transistor is formed by placing an N-type material between two P-type materials. Similarly, an NPN transistor is formed by placing a P-type semiconducting material between two N-type semiconducting materials. So, based on the construction of transistor, the transistors are classified into two types, NPN and Pnp transistor. So, the NPN transistor is formed by placing an N-type material, P-type material, P-type semiconducting material between two N-type semiconducting materials. As we all know that we have two types of semiconductors. Those are extrinsic and intrinsic semiconductor. Intrinsic semiconductor means what? It is a pure semiconductor, whereas extrinsic semiconductor means adding the semiconductor which is added with some impurities. So we have two types of impurities. What are the two types of impurities we have? That is trivalent impurity. We have trivalent impurity and pentavalent impurity. So adding trivalent impurity to the pure semiconductor leads to P-type semiconductor. That means I wanted to tell you about, recall some basic concept of semiconductor. So where in P-type semiconductor, holes are the majority charge carriers and electrons are the minority charge carriers. I hope you all know this. Just I am recalling the concept. So holes are the majority charge carriers where electrons are the minority charge carrier. What do you mean by majority and minority? Majority means more in number, minority means less in number. So that means in a P-type semiconducting material, electrons are present in less number, whereas holes are present in more number. So, and if we add pentavalent impurities, we can have N-type semiconducting material, where in N-type semiconducting material, electrons are the majority charge carriers, where the holes are the minority charge carriers. So what we are doing here, we are taking two types of semiconducting materials, that is N-type and P-type semiconducting material. If an N-type semiconducting material is placed or else sandwiched between two P-type semiconducting materials, then a Pnp transistor is formed. Similarly, if a P-type semiconducting material is placed or sandwiched between two N-type semiconducting material, an NPN transistor is formed. So here this is the construction of NPN and Pnp transistor. So here these two are the two N-type semiconducting bars. In between we are placing a P-type material so that if an NPN transistor is formed. And similarly we have two P-type semiconducting bars, and in between we have an N-type semiconducting bar which results in a Pnp transistor. So as we have three types of semiconducting bars here, so we can take three terminals out. So each from each semiconducting bar. So here we can take one terminal from this semiconducting bar, one terminal from this, and one terminal from this. So that is why we are saying that a transistor is a three-terminal semiconducting device. Okay. So here the three terminals of a transistor are emitter, base, collector. And what are this emitter, base, collector? We'll see now. So this is the construction of NPN and PNP. And as I already told you that, so this NP is nothing but a PN junction diode. So whenever we are placing N-type and P-type semiconducting material, there will be a junction formed. So there we have a junction in between this and NP. And similarly, we have a junction in between these. So that means we can say that a transistor is a 3-terminal and 2-junction device. Okay. So here also P and N, this can form a junction here, and N and P, this can form a junction here. And as I said you that this transistor is a back-to-back connection of 2 PN junction diode. So here let us see, this is N-type and P-type. N-type material forms the negative terminal of the diode, and P-type material forms the positive terminal of the diode. So this is the back-to-back connection of, and this is P, right? So P and this one. So this one is nothing but, this is N, this is P, and this is P, and this is N. So this forms an NPN transistor. What is this one? This is the cathode and anode. This is again anode and cathode. So this is nothing but the back-to-back connection of 2 PN junction diode. This is NPN. Whereas in case of PNP transistor, first is P-type material. P-type material gives you anode terminal. So this is P-type material. So this is anode and cathode. So here we have again a cathode, back-to-back connection. So cathode and this is anode. So what is this one? As we are taking anode terminal, this must be P-type material. This must be N, N and P. So that means what is the transistor it is resulting? A PNP transistor. So that is why what I said, a transistor can be constructed by connecting the 2 PN junction diodes back to back. So depending on the connection of 2 PN junction diode back to back, we can have 2 types of transistor. That is NPN and PNP transistor. And if you observe this construction, as we have 3 types of 3 semiconducting bars, we can take 1 terminal out from each semiconducting bar, and hence we can say that BJT or else a transistor is a 3-terminal device, and the 3 terminal that we can take out from this transistor are called as emitter, base, collector. So what is emitter? So the terminal which we are taking from the left side semiconducting bar is called as emitter. So which in short we can also represent this as E. Whereas from the right side semiconducting bar, whatever the terminal we are taking is called as collector terminal, and the terminal which we are taking from the middle semiconducting bar is called as base. Emitter, base, collector. Emitter is the leftmost semiconducting bar, the terminal taken out from the left semiconducting bar, and collector is the terminal taken out from the right semiconducting bar, and the base is a terminal taken out from the middle semiconducting bar. So similarly, we have emitter, and this one is collector, and this one is base. So here if you observe, in NPN transistor, so if you observe that emitter and collector are N-type. Okay, emitter and collector are N-type materials, whereas base is P-type, because we are taking the base terminal from the middle semiconducting bar. What is the middle semiconducting bar in NPN? It is P-type. So base is P-type and emitter and collector are N-type. If you consider PNP transistor, so emitter and collector are P-type, whereas base is N-type. That you have to remember. Okay. So in NPN transistor, emitter and collector are N-type and base is P-type. Whereas in PNP transistor, emitter and collector are P-type and base is N-type. So now let us discuss about what is emitter, collector and base. What are the main functionalities of emitter, collector and base, and why these terminals are named as emitter, base and collector. So first of all, let us see emitter. What do you mean by emitter? So the emitter is the terminal taken out from the left hand side semiconducting bar, and here this emitter is moderate in size, and that means the size of the emitter terminal is moderate and it is heavily doped. And the main function of this, the main functionality of this emitter terminal is to supply the number of majority charge carriers. So here in NPN transistor, if you consider emitter is N-type, right? So the majority charge carriers will be what? Will be electrons. Whereas in PNP transistor, emitter is P-type. So what about the majority charge carriers in PNP transistor? Holes are the majority charge carriers. If holes are the majority charge carriers, what about the electrons? That will be considered as minority charge carriers. So here the majority charge carriers are supplied by the terminal emitter. So here, and it is heavily doped. So as it is heavily doped, it can supply more number. As it is heavily doped means what? We are adding more impurity atoms to the pure semiconductor so that more number of majority charge carriers are created. So that as the emitter terminal is heavily doped, so it can create more number of majority charge carriers. So we have to remember that the main functionality of emitter terminal is to supply the number of majority charge carriers. That is either electrons or holes. Electrons in case of NPN transistor and holes in case of PNP transistor. As this electrons, as this terminal emits electrons, we are calling this as this terminal emits the electrons or holes. That means as this terminal is emitting or is generating the majority charge carriers, we have named this terminal as emitter. So which is represented by a letter E. So next what is the terminal? Base. What is this base terminal? So here the terminal which is taken out from the middle semiconducting bar is called as base terminal. And you have to remember, base is very thin and lightly doped. So as I told you that emitter is heavily doped and the size of the emitter is moderate. That means it is neither high nor low. That means neither thick nor thin. But here base terminal is very thin. It is also lightly doped. Lightly doped means what? Number of majority charge carriers will be less because we are adding less number of impurities so that it can create less number of majority charge carriers. And what is the main functionality of this base? The main functionality of the base terminal is to pass the majority charge carriers from the emitter terminal to the collector. Okay, so this is the main functionality of the base terminal and it is represented with capital B. Now coming to the collector terminal. What is a collector terminal? So as the name itself indicating, collector. So what is the main functionality of this one? It is to collect the majority charge carriers generated by the emitter. So the terminal that is taken from the right side semiconducting material is called as collector terminal. Coming to the size of this one, the size of the collector terminal is large, whereas the emitter is moderate and base is thin. But here the collector is the size of the collector is very high, and the doping of this collector terminal is moderate. So you remember, doping of emitter is high and base is low, whereas the collector is moderate. Coming to the sizes, the size of the emitter is less and collector is more. Emitter terminal is moderate and the collector terminal is more, whereas the base terminal is very less. So here the size of the collector is very big or else large in size, and the doping is moderate. So it is indicated by letter C. And what is the main functionality? As I said you that it has to collect the charge carriers, majority charge carriers generated by the emitter. So here now let us see the symbols of and why we are making this terminal collector terminal as large in size. Because as the charge carriers are generated by the emitter and these are collected by the collector, whenever it is collecting the majority charge carriers, so there will be more current flowing, due to which heat will be generated. So in order to generate that heat, in order to dissipate that heat, we need to have the size of the collector as large as possible. So we have an example, cup and saucer. Why we are using the saucer? In order to make the coffee or tea cooler soon, so we are using the saucer. If you pour some coffee or tea in the saucer, as its surface is wider, it gets cooled very fast so that we can have it fastly. So that is the reason. So the same thing we can apply, the same theory we can apply to the collector. As the collector is collecting the charge carriers, so more current will be flowing through the collector junction, due to which, so there will be some kinetic energy to the charge carriers. So due to which there will be some heat generated, and in order to dissipate that heat, the collector terminal is made more wider when compared to the emitter and base terminal. That is the reason why we are choosing this collector terminal as big as large as possible. Okay, now coming to the symbols of NPN transistor and PNP transistor. So this is NPN transistor. As I told you that from the first N-type semiconducting material, we are taking the emitter terminal, and from the middle P-type semiconducting material, we are taking the base terminal, and from the last N-type semiconducting material, we are taking the collector terminals. So collector, base, emitter. And as I told you that the transistor is nothing but back-to-back connection of two PN junction diode. We'll have two junctions, one between emitter and base terminal, which is called as base to emitter junction, and one more junction between base and collector terminal, which is also called as base to collector junction. So here we have two junctions in a transistor, one between the emitter and the base terminal, which is also called as base to emitter junction, or else we can also call it as emitter junction. We can also call it as emitter junction. Whereas one more junction is between base and collector, we can also call it as collector junction. So this is a 3-terminal 2-junction device. And now this is a PNP transistor, where emitter is P-type and collector is also P-type, whereas base is N-type. Similarly, as we are connecting two PN junction diodes back to back, we'll also have two junctions here, one between emitter and base and the other one between collector and base. So these are the symbols here. So always you remember NPN stands for never points in. So that means here this is the symbol. The bar indicates the base terminal and the remaining terminals are collector and emitter. So here now this arrow indicates the direction of conventional current. What do you mean by conventional current? This is the current due to the motion of holes, that is positively charged. So this is the direction of conventional current, and here for an NPN transistor always the arrow mark will be pointing out. So that is why we are calling it as never points in. NPN stands for never points in. That means by looking at this statement, we can remember the direction of arrow in NPN transistor will always be outside. It will never be inside. So that is why it is outside. Now coming to the PNP transistor, PNP stands for points in permanently. Points in permanently. So that means the arrow direction will be into the emitter terminal. Whereas in NPN, the arrow direction of arrow will be coming out of the emitter terminal. So this is the base again, collector, emitter. And one thing you have to remember. So here arrowhead in the above figure represents the that means how to identify the terminals here. So whatever the terminal which is having arrow is always considered as emitter. The other terminal is collector, and the terminal taken from the bar is considered to be base. Okay, so that means you have to identify the terminals of a transistor in such a way that the terminal which has received an arrow mark indicates the emitter terminal, either in case of NPN transistor or PNP transistor. Only the thing is, in NPN transistor, the arrow will be outwards, direction of arrow will be outwards, whereas in PNP transistor, the direction of arrow will be inside. Okay, so The collector of transistor, so as I told you that as the collector has to dissipate much power, it is the size of the collector is made large when compared to the emitter. And here one more thing. So here you may think that in an NPN transistor or PNP transistor, if whatever the type of transistor you consider, emitter and collector are same type of materials, right? Either N-type or P-type material, right? In NPN transistor, emitter and collector are N-type, whereas in PNP transistor, emitter and collector are P-type. But here, even though those are of same type, but we cannot interchange them. That means the emitter and collector terminals are not interchangeable. Why we cannot interchange them? Because the doping levels of emitter and collector are different, and even the sizes of emitter and collector are also different. Whereas the size of the emitter is moderate, whereas the size of the collector is high. So even though those are of same type of materials, but we cannot interchange them due to the reason that the doping levels of emitter and collector are different, and even the sizes of emitter and collector are different. So as I told you that in a bipolar junction transistor, we have two junctions. One is emitter to base junction and the other one is collector to base junction. And I said you that the transistor is also called as a bipolar junction transistor. In short, we can also call it as BJT. Why we are calling it as bipolar junction transistor? Because in a transistor, the current conduction or else the flow of current is due to both majority and minority charge carriers. That is due to either free electrons and holes. So that is why as the current conduction is due to both electrons and holes, we are calling it as bipolar junction transistor. Whereas in case of normal PN junction diode, under forward bias condition, the current is due to only majority charge carriers. Whereas under reverse bias condition, the current is due to only minority charge carriers. But that is why the PN junction diode comes under unipolar device. That is, in either the current is due to majority or minority charge carriers. But in case of BJT, where the current is due to both majority and minority charge carriers, and hence this is also called as bipolar junction transistor. Okay, and here now coming to the biasing. So whenever we want to operate any semiconducting device, we need to provide some external DC supply. So applying the external power supply to control the operation of any device is known as biasing. Okay, so how to bias a transistor? So you always remember, as the emitter has to generate the majority charge carriers, you remember that emitter should always be forward biased, whereas collector has to collect the charge carriers. It is to be reverse biased. And one more thing, in order to the major purpose of transistor is amplification. In order to operate the transistor as an amplifier, always you remember we have two junctions. What are the two junctions? Emitter base junction and collector to base junction. So in order to perform the amplification operation, always you remember emitter to base junction should be forward biased and collector to base junction should be reverse biased. Okay, so as the emitter has to generate the charge carriers, we have to always forward bias the emitter junction. And as the collector is to collect the charge carriers, it is always to be reverse biased. So this is the PNP transistor we are considering, and we are providing the external supply, DC supply. That means we are biasing the transistor such that emitter to base junction is forward biased and collector to base junction is reverse biased. What is the emitter terminal? P-type. In order to forward bias the emitter terminal, what should we do? We should connect the positive terminal of the battery to the P-type material so that this emitter to base junction will be forward bias. So positive terminal of VEE, external supply, I am naming it as VEE, is given to the emitter and negative is connected to the base terminal. And similarly, collector is to be reverse biased, as I told you. What is the type of collector? P-type. In order to reverse bias, what should we do? We need to connect the negative terminal of battery to the P-type collector. So negative terminal is connected here and positive terminal is connected. So this is emitter, base, collector, and this is the biasing provided such that emitter to base junction is forward biased and collector to base junction is reverse biased, right? And due to that, we'll have currents, and how these directions of these currents we'll be discussing when we are discussing about the operation of transistor. Just look at this diagram, how we are providing the biasing such that emitter junction is forward biased and collector junction is reverse biased, right? So this is Pnp transistor. So points in permanently. So we always, the arrow mark should be inside, and this is the base terminal. That means, so what I'm doing, I'm replacing the transistor with that symbol. So base terminal, emitter, collector, and the biasing provided here. And this is NPN. So whatever it may be the type of transistor, emitter should be forward biased and collector should be reverse biased in order to perform the amplification operation. So VEE, so as it is NPN transistor, emitter is N-type, so negative terminal is connected here. Again, collector is N-type. In order to reverse bias, positive terminal of the battery is connected here. Okay, so this is the biasing provided to the NPN transistor, and this is the symbol of the transistor here. So the arrow direction is always outside. This is the NPN transistor, and the biasing provided to the NPN and PNP transistor such that emitter junction is forward biased and collector junction is reverse biased. Now, let us see the operation of NPN transistor and PNP transistor. So, as in the above diagram, so all these directions of currents, we have three currents here: emitter current, collector current, and base current. So, the directions of currents, these are all the conventional current directions. Okay. Now, operation of NPN transistor. So now, as we all know that the normal operation, the main purpose of transistor is for amplification. So how can the transistor, a transistor perform amplification operation? By making the emitter junction forward biased and collector junction reverse biased. So here, as the emitter junction is forward biased, so as I told you that whenever we have a transistor, whenever we place two different types of semiconducting materials together, junction will be formed. As I am providing forward bias to the emitter to base junction, that is a junction formed between emitter and base terminal, as it is forward bias, the width of the depletion region will be narrow. Whereas the collector to base junction is always reverse biased in order to perform the amplification operation. So as the junction is reverse biased, the width of the depletion layer at the collector to base junction will be wide. That we have to remember. When emitter junction is forward biased, what happens? And when collector junction is reverse biased, what happens? So now let us see. So this is an NPN transistor. We are providing the biasing such that emitter to base junction is forward biased and collector to base junction is reverse biased, right? So now what happens when emitter junction is forward biased? So as I told you that we have a narrow depletion layer at the emitter base junction, whereas we have wider depletion region at the collector to base junction. Okay, so I have shown it with red color dotted line here. So this one is my depletion region, and as it is wider because the collector to base junction is reverse biased and it is narrow at emitter to base junction. So this is nothing but JE, let us consider emitter junction, and this is JC, that is collector junction, right? So now what happens when emitter to base junction is forward biased? So what is the type of transistor here? NPN. What are the majority charge carriers of an N-type semiconducting bar? Electrons are the majority charge carrier. So I have shown this as electrons. Okay. So now what happens? Electrons are negatively charged. So we are connecting negative terminal of the battery to the N-type semiconducting bar. So the electrons will be repelled by the negative terminal of the battery, and they will be moving towards the base terminal. I hope it is clear. So as electrons are negatively charged and these are repelled by the negative terminal of the battery, and they will always be moving towards the p-type base terminal. Okay, so that means the direction of electrons is this way from N to p-type base. Right. So, and what is a p-type? What is a base terminal? It is a p-type material, and we already know that base is lightly doped. Lightly doped means the number of majority charge carriers will be very less. So, what are the majority charge carriers of p-type base terminal? So, the p-type base terminal, the majority charge carriers are holes. So, as the depletion region is very less, whenever the applied voltage exceeds the potential barrier at the emitter to base junction, so the electrons, initially the electrons cannot cross the junction, cannot enter into the P. Whenever the applied voltage exceeds the V gamma, what is V gamma? Cut-in voltage, either it is 0.7 or 0.3, 0.7 for silicon or 0.3 for germanium. Whenever it exceeds, then the electrons can cross the depletion region and enters into the p-type material, p-type base region. Where in p-type base region, the majority charge carriers are holes and the minority charge carriers are electrons. So whenever these electrons enters into this p-type material, these electrons will recombine with the holes present in the base region. So as it is lightly doped, so very less number of majority charge carriers are present, and hence only very less number of majority electrons will recombine with the holes. Okay, so that means let us consider only 5% of electrons will recombine with the holes present in the base region, and remaining 95% will be entering into the collector region. Why these are entering into the collector region? Because these electrons are attracted by the positive terminal of the battery, which is connected to the collector terminal. So these will be moving towards the collector terminal and they will be entering into the collector terminal. And hence 95% of majority charge carriers will be collected by the collector terminal. Only 5% will be recombined with the holes of base region, which leads to some current flow across the base terminal, which is represented as base current. So in the given amount of current, emitter current, that is IE, only 5% is flowing through the base terminal, that is due to the recombination of electrons and holes in the base region, and the remaining 95% of the electrons or majority charge carriers are collected by the collector terminal, which leads to some current flow through the collector terminal, that is IC. And now, how about this direction? So as the electrons are moving here in this direction, what about the whole direction? So we do have minority charge carriers in the N-type semiconductor. What are the minority charge carriers? Holes. So the holes will be attracted by the negative terminal of the battery. So and hence the holes are moving in this direction and electrons are moving in this direction. As we all know that the direction of motion of electrons and holes is opposite to each other. So always we have to consider the conventional current direction as the direction of motion of positively charged carriers, which are nothing but holes. So what is the holes direction here? These are moving from N-type material to the negative terminal of the battery. So that is why the current direction is this one. And similarly, due to the recombination, some current is flowing here. So here in p-type material, some electrons are present, which are minority charge carriers. They will be attracted by the positive terminal. So as the electrons are moving in this direction, so the current direction will be opposite to the direction of motion of electrons. So as the electrons are moving in this direction, the current direction will be upwards. Whereas coming to the collector current, so the electrons are entering the collector and these are attracted by the positive terminal of the battery. So this is shown by the arrow marks here. So this is the motion of electrons. So as the electrons are moving in this way, what will be the direction of current, which is opposite to the direction of motion of electrons. Why? Because electrons are negatively charged and hence the current direction will be opposite. So now the current is into. Or emitter is outside, emitter current is outside, whereas base and collector currents are inside. Okay, so this is the operation of NPN transistor. So you have to remember that whenever the majority charge carriers are crossing the junction, they will recombine with the majority charge carriers of base region, and the remaining will be collected by the collector region. As the base terminal is lightly doped, there is less number of majority charge carriers present, and hence only few majority charge carriers will be recombined, which leads to very less amount of current flow through the base terminal, and more current will be flowing through the collector terminal. So that is the operation of NPN transistor. So as we all know that there are three currents flowing, we can identify three currents in the BJT. What are those? Emitter current, base current and collector current. So here majorly, what are the majority charge carriers of NPN transistor? Electrons. So and hence the current conduction in NPN transistor is majorly due to the electrons, whereas even we have current conduction due to the minority charge carriers, that is holes, but it is very less. So the increase and decrease of emitter current affects the collector current. And coming to the PNP transistor. So the operation is same. Only the thing is, in PNP transistor, majority charge carriers are holes. Majority charge carriers are holes, whereas minority charge carriers are electrons. Why? Because emitter is p-type. That is why majority charge carriers are holes. Okay. Now, whatever it may be the transistor, as I told you that emitter base junction must be forward biased and collector to base junction must be reverse biased. So, we have provided the biasing such that emitter to base junction is forward biased and collector to base junction is reverse biased. Now, what happens? As it is PNP transistor, emitter is p-type, base is n-type and collector is also p-type. So, as it is p-type, what are the majority charge carriers of p-type semiconducting material? Holes. Holes are positively charged. So, as the holes are positively charged, they are repelled by the positive terminal of the battery and hence they will be moving towards the n-type base region. So, as it is n-type base region, again the n-type material is lightly doped, that is base is lightly doped. So, there are less number of majority charge carriers which are electrons in the base region. So, once the applied potential is greater than V gamma, so these holes will cross the junction and enters into the n-type base and they will recombine with the electrons majority charge carriers of base, and which leads to some recombination current to flow across the base terminal, and the remaining majority charge carriers that are holes are entering into the p-type material, and these are attracted by the negative terminal of the battery because holes are positively charged. So, they are always attracted by the opposite charge. So, these will be moving towards this. And here, there is some minority charge carriers in n-type base. What are those minority charge carriers? Holes are the minority charge carriers. So, holes will be attracted by the negative terminal of the battery. So, and they will be moving like this, and hence the direction of base current is this way. Whereas, holes are moving in this way. So, the direction of conventional current is always equal to the direction of motion of holes. So, as the holes are moving in this direction, the current direction is also this way. So, that is why emitter current is entering in p-type PNP transistor. And whereas base current is leaving. And what about the collector current? So, the holes are attracted by the negative terminal. So, holes are moving from p-type to the negative terminal of the battery. So, that means holes are moving in this direction and hence even the current is outwards. So, that means IE is inward into, whereas IB and IC are outwards. So, this is about the PNP transistor. So, as we can observe here, again three currents, emitter current and base currents, and I have shown the conventional current directions of emitter, base and collector here. You have to remember, in case of NPN transistor, emitter current is outwards, whereas base and collector are into. Whereas in case of PNP transistor, emitter current is into, base and collector are outwards. So here, now coming to the symbol and direction. So if you apply the KCL at the transistor, that is, what do you mean by KCL? These are all the points which we have discussed here. So here one thing you have to remember. In PNP transistor, holes are the majority charge carriers and electrons are the minority charge carrier. In both the type of transistor, there is some current flowing due to both majority and minority charge carriers. Okay, so the increase or decrease in the emitter current will always affect the collector current. So as we all seen this direction of conventional current. So if you apply the KCL here, what is KCL stands for? Kirchhoff's current law. What is the statement of that? The currents entering a node is equal, the sum of currents entering a node is equals to the sum of currents leaving a node. If we consider this transistor as a node, so what are the currents that are entering the transistor? IE. What are the currents that are leaving here? IB and IC are leaving. So if we apply KCL, that is Kirchhoff's current law, we can have a relation between all the three currents as IE is equals to IB plus IC. IE is equals to IB plus IC, where IB is the base current, IC is the emitter current, and IE is the IE is the emitter current, IC is the collector current. So these are the transistors with the flow of current in the transistor and the directions of current. So as it is NPN transistor, so as we all know that never points in, so emitter current will be always outwards, whereas the base and collector current will be into. So if we consider PNP transistor, always points in, so emitter current will be always entering, whereas base and collector currents are leaving the terminal. So again, if we apply the KCL here, we can have IE is equals to IC plus IB. And this equation holds good for both NPN transistor and PNP transistor. That means this is valid equation for both NPN transistor and PNP transistor, that we have to remember. And now, what are the advantages of transistor here? High voltage gain. What do you mean by gain? Gain stands for output voltage to the input voltage. So as I told you that the transistor is used for amplification in order to increase the strength of the weak signal. So if we have output voltage as high, then we can have high gain, right? So low supply voltage is sufficient. That means we need not to apply more supply voltage. We can apply, even this transistor can operate in the range of 0 to 30 volts, and more suitable for low power applications. So next, the smaller and lighter in weight. The transistors are very smaller and very lighter in size, and mechanically stronger than vacuum tubes. So these are, when compared to the vacuum tubes, these are mechanically strong, and no external heating required like vacuum tubes. So that means in order to provide the heat, reduce the heat dissipation, we need to have an external circuitry, whereas it is not required in transistors. And it is very suitable for integrated circuit design, that is ICs design, where we are going to integrate the resistors and diodes in order to generate ICs. So coming to the disadvantages here, they cannot be used for high power application. As I told you that this can be used for only low power applications. So we cannot use this for high power applications due to lower power dissipation. That means it cannot dissipate more power. So if you use it for high power applications, the transistor may get damaged. And though they have lower input impedance. So the input impedance is low, means the current will be very high. So that is a major drawback of this one. And they are temperature dependent. That means even the variations in the temperature can also vary the currents flowing through the current. So that is also one drawback we can consider for the transistor. So this is about the transistor operation and the advantages and disadvantages. So the transistor is a 3-terminal device So as it is a 3-terminal device, we can connect the transistor in 3 configuration by taking any one of the 3 terminals as common and the remaining 2 terminals, one as input terminal and the other as output terminal. So based on this, I can have 3 types of configuration. That means we can connect a transistor in 3 types of configuration by taking any one of the 3 terminals as common and the other 2 terminals as one as input and the other as output. So we can have 3 configurations for a transistor. One is common base, common emitter and common collector. So these are the 3 types of configurations in which we can connect a transistor in order to perform the amplification operation. I hope that is clear. You are clear with the operation, construction operation, and the symbols of transistor. The symbols of transistors are very important, and the directions of current is also very important. I hope you all are clear with the operation of NPN transistor and PNP transistor. So whereas the operation of both NPN and PNP is same, only the thing is majority charge carriers and minority charge carriers will be varying. So that's all for today. We'll discuss the characteristics of transistor under 3 different configurations in the next class. Thank you one and all.
Like, share and subscribe. Hit the bell icon for more updates.